The problem reads, find the roots of x to the fourth plus 16x minus 12 equals 0. So, the first thing I notice is this is a quartic. Quartics are annoying. But, although there is technically a quartic formula that would get us straight to the answer, that is a long path to take, and it is not a formula worth remembering. What we can instead do is we can try to express it in this form. Basically, from here, what we can end up doing is we can move the bx plus c squared to the right side, and then square root both sides. And this is obviously just a quadratic, two quadratics that you can just solve. So let's try factoring into this form now. Let's first expand this form. And instead of setting this equal to 0, what we can do is we can set it equal to the original expression and try to combine them. So obviously this x fourth term works. For the x squared term on the left side, we actually have to have it equal to 0 because the x squared term in these two. We have to have this be 0 because there is no x squared term in the original equation. And then for the x term, we only have a single term, so negative 2bc equals 16x. And then for the negative 12 term, that's just a squared minus c squared, because those are the only constant terms here. From here, you can get the three equations: 2a minus b squared equals 0, negative 2bc equals 16, and a squared minus c squared equals negative 12. Okay. From this top one, we get 2a equals b squared, a equals b squared over 2. We're just solving a system of equations now. bc equals negative 8, c equals negative 8 over b. And then this bottom one here, we can substitute in these two values and get b to the fourth over 4 minus 64 over b squared equals negative 12. Now, in order to solve this, we can set 4d equals 8b squared, which will nicely cancel with this 4 here. This takes us to 16d squared over 4 minus 64 over 4d equals negative 12, which simplifies to 4d squared minus 16 over d equals negative 12. From here, we actually notice, if you look at just the coefficients here, 4 minus 16 is negative 12. So if we just remove the d terms by setting d equals 1, that's a solution. There could be more solutions, but we won't bother exploring for that. Now we can substitute back into this. 4 equals b squared, which means b equals 2. Technically, it's plus minus 2, but here the plus minus doesn't end up mattering. So let's just run with b equals 2 here. From here, we plug this into this, and we get a also equals 2. And then we can also plug this into here to get c equals negative 4. Now we can go all the way back up to this here. X squared plus 2 squared minus 2x minus 4 squared equals 0. We can do what I mentioned earlier, where we move the second term to the right side. Square root both sides. Note that we do get plus minus, so we do have to split into two quadratics. Move the terms over. And the first thing I'll end up noticing is that in this first one, the discriminant is less than 0. It is negative 20. So we can actually just ignore this one, because it will not give us real roots. And this problem doesn't specify it, but it is only looking for real roots. In this one, we can just plug it into the quadratic formula and get that the roots are x equals negative 1 plus or minus root 3. And that is our answer.